Hello again and welcome back. In this lesson, I'm going to cover the output coordinate system environment variable. This environment variable is important because it controls the coordinate system that the analysis of a geoprocessing tool is conducted in. So if your data is in different projections or coordinate systems, or just different from that environment variable, then that data is going to be reprojected behind the scenes to that output coordinate system for the analysis, and then your data will be written out in that output coordinate system as well. There are many cases where this is pretty inconsequential, but in the case of rasters, which we learned can get resampled when you reproject them, you can get data shifts that could be minor or could be potentially significant depending upon the work you're doing. So let's take a look at that in action. We'll use the zonal statistics as table tool again. And for the input zone data, I'll use this parcels layer I have, and I'll select object ID as the zone field, and I'll select the digital elevation model here as my input raster. And I'll accept the default output location, but I'll call it zonal UTM. And in the environment settings, I'm going to go set the output coordinate system environment setting here. So under output coordinates, it has the same as input setting here. And generally speaking, that takes the coordinate system of the first input item and uses that instead of setting the output coordinate system directly here. So I know that the parcels layer here is in a UTM coordinate system, but let's just make it explicit. And so I'll choose same as layer parcels 30. And what it does is it sets the coordinate system directly here. And if you were to click OK, and then go back into environments now, it doesn't say same as layer parcels 30, it now says as specified below, but it took the coordinate system off of that layer and specified it here. So a lot of times people get confused because they think that they set it as the layer and then they come back into environments and realize that, oh no, it's specifically specified instead. I want it to be same as layer, and so they set it again and the process repeats. So know that if you come back to environments after setting it to the same as a layer, it will just be specified. So even though this is the default, we're going to be explicit here, set this environment setting, and I'll click OK. And let's just get the mean value in the zonal statistics, and I'll click OK. And while that's running, let's set up another run of this. And in this run, we're going to use a different output coordinate system. So again, I'll select object ID and value raster of this digital elevation model. And in this case, I'll call it zonal Albers, because that's the projection I'm going to use. I'll use an Albers projection optimized for the United States. And I'm going to click environments and go back to output coordinate systems environment setting again. And this time I'll choose as specified below. And I will find that coordinate system that I want, which is under projected coordinate systems, continental, North America, and then NAD 1983, contiguous USA Albers. I'll click OK. And then close environments and run the tool. And the reason I'm running this twice is that I want to show you that the data that we get on zonal statistics differs slightly between these two runs. And again, that's because the raster gets resampled. The fact that I'm running this analysis in a different coordinate system means that it still has to match the coordinate systems between the data sets, so it reprojects the raster and then it reprojects the features if necessary so that they match the output coordinate system, and then does the analysis in that coordinate system. So let's do a quick analysis here. And before I do my join, I got an error earlier in setting up for this, so I'm going to add my field for comparison right now. I'm going to add a field for differencing the two values. And I'm going to make that a double as well, because the mean looks like it's either a floating point or a double field. And then now that I have that field, let's do a join. Let's join the data from the zonal Albers table to the zonal UTM table. It's object ID 1 in this case because I did a join, or I did the zonal statistics based on the object ID field, but it assigned an object ID field to the output table. So object ID 1 actually matches the data between the two tables. And I get zonal Albers as the table to join, and let's do a validate join. And all but one of them match. And I suspect that that missing one is because the projection actually made a parcel not pick up data on one of the two zonal stats runs. So I'll click OK now, though, because it's pretty good. It looks like they match. And at first, mean is 127, and it's 127 here. Okay, but the decimals are different here. And let's kind of quantify how different these values are, since we now know that running them in two different coordinate systems, we get different values out of it. If we ran it again in the same coordinate system, we're not getting some sort of entropy in the system. It would have given us this exact value back if we ran it in the same coordinate system that gave us this value first. So the differences here really are explained by the difference in coordinate system. And if I use the field calculator, and just so you get to see the syntax, I'll switch to Python and I'll use zonal UTM dot mean, and I'll subtract the zonal Albers mean. And I'll click OK. Calculates the field for me. And I can see that there's a difference of an absolute value difference of 0.316 between these two values. Let's sort this though. And we'll see, yeah, we got one null value where it didn't find a record to join. The projected version, this is the Albers one that we joined onto the UTM one, didn't actually pick up any data. The parcel must have been outside of the layer. But moving on, we can see that on some of these, we had a difference of 4 between the two different versions of this analysis that we ran. That's relatively significant, getting a difference of 4 meters between 198 and 202. And there are a handful at these kind of outer extremities, not too many. And then we get mostly into, it looks like most values are less than 1.5, and then most of them are less than 1, and we probably have some sort of relatively normal distribution here. But then on the other end of it, we go all the way up to 3.5. And if I really want to summarize this, I could go to statistics and get this box popping up. Oop, I have a record selected, so it's only giving me that one. So I'll deselect the records and then go to statistics again. And I can see that, yeah, it looks relatively normal here. And most of the values are within pretty close distance of 0 difference between the records, but they get out pretty far. A handful of records are between negative 0.6 and negative 1.3 here, and a bunch are still between 0.8 and 1.4 over here. So we do have some variance. There are plenty of applications where this variance doesn't matter, and you may not care to bother with your projections and coordinate systems enough. But where precision matters, and it might for many of you, know that you should be checking your projections on your data and be aware of the output coordinate system that your data is running in. If all your data is in one coordinate system, you have no problem. That's what it's going to run your analysis in. But in the event that you had data in different coordinate systems, if my parcels were in the contiguous USA Albers projection, but my DEM was in UTM, I might have run that and not thought about the fact that in the background it was reprojecting my raster and changing the data. So the output coordinate system environment variable does matter. It does have real results on, or a real impact on the results of your analysis. Okay, that's it for this lecture. In this lecture, I showed you the output coordinate system environment variable, which controls not just the coordinate system of the output of your geoprocessing tool, but also the coordinate system that your analysis is performed in. We saw that if we ran the same analysis with two different projections in that environment variable, we got slightly different results for each record. This is one of my most commonly used environment variables, and it might be for you too. In the next lecture, we'll continue with environment variables by taking a look at the extent environment variable. See you there.